Hi, this is Colin Melia, here to talk to you about an introduction to serverless functions. Let's look at the path that gets you down to serverless functions. In the cloud, for some time now, we've had infrastructure as a service. That means our VMs, or even before the cloud, we had on-premise and still have on-premise solutions. Setting up a unit of compute to just run a simple function on an on-premise server means, of course, setting up that server, installing the operating system, installing some framework on which to run, and of course, writing code and installing it and making sure it all works. If you want to scale up that, we'd have to consider, having more machine or more machine power. With infrastructure as a service, we had some other choices. We could, of course, switch to a more powerful VM and just move the disk image to that other machine. And of course, along came platform as a service. Platform as a service provided the ability to be able to just take our application and basically throw it up to the cloud. And as long as it conformed to a certain set of shape, or like, for example, an ASP.NET application or a PHP application, we can run it in something like IIS, and it would just neatly slot in there and run to its heart's content. However, we still need to spin up that whole service and use that whole and reserve that whole compute at some level, even if we're just using a single function and it only ever gets fired on a Wednesday. So what we need is something like functions as a service, and this is where Azure Functions comes in. So we're going to take a look at Azure Functions and see how those work, how you get a single function or method that you can call and have it scale up without having all of the surrounding infrastructure that you would have with PaaS or IaaS. So the benefits are obvious. Hopefully, there's reduced DevOps costs in terms of what it takes to get your function ready. And you'll see that as we code, there's not a lot you have to do to get a function in action. And of course, from the operational IT pro side of things, you're not setting up a server, you're not provisioning a complicated VM, and you're not even provisioning a service on Azure like a PaaS service, like Azure App Service. We're not even doing that necessarily. We can focus on the logic, which means that we can build simple pieces. And sometimes you only need a simple piece. You don't need a whole application. You just need something quite simple. There's also reduced time to value. Some people say reduced time to market, but I like to say a reduced time to value where you're actually getting value out of what you've produced. And of course, rather than producing monolithic applications and all the supporting bits and pieces that go with them, we're just producing microservices. So let's see how easy it is to get started with Azure Functions. So I just went to functions.azure.com/try, and it's giving me a unique ID because of my private browsing experience. So it's like I'm doing it for fresh at the moment. I can pick how my function is initiated, and I can pick the language. And then I just go ahead and, for example, click Web API, a webhook, and C# and click Create this function. I'm not going to do that. I'm actually going to go back over to here and do /try. Since I already went into this, it's going to take me straight to the selection I already made before. So you see in this case I have 45 minutes left because I already started it. If I run out of time, I can actually just start again and just lose the coding that I actually did before. So here we are, we're in the web browser still, and this is where we're doing the coding, either C# or JavaScript, and you'll actually see there's some code there. I'm just going to pop into here, into integrate, and change this authorization level to anonymous. I want to save that and go back to develop. So we'll give this code a run. And the way we'll do that is we'll just copy this URL, we'll open another tab in the browser, and we'll just run it. So it says, please, pass a name or a string, or query string in the body or a query string. So let's just do name equals hi. There we go. So it says hello, hi. If we go back, you can see it's actually searching for both query strings or data inside the form that's posted, and these are the messages that you saw. So I just got this code, put it there, and now it's already available on an endpoint. I can call it and do things with it. So it's really kind of simple to get started, And there's an awful lot more you can do, as we'll see. So these are actually the target languages that Azure Functions should eventually be available in. There's quite a lot there, obviously C# and JavaScript, also F#, that's accessible now to some extent. Python, PHP, Bash, Batch, and PowerShell are all target languages that potentially might become available using Azure Functions. That's quite a lot. Now, there are ways you can actually trigger a function. You can have an internal timer, so every so many minutes, like using a cron expression like you would use on Unix or Linux, you can fire off a specific function, have it do something. And the one we just saw is a web request. So this would be like a REST endpoint passing in JSON or just some standard post messaging or just a query string, or it can be more of the webhook style, which means that, for example, I could create my Azure function, get the URL for the Azure function, and put that into some other service. Maybe it would be GitHub when a pull request occurs, or it could be WordPress when a comment occurs. So what I can take my URL, put it in somewhere into another service where a callback URL or URI is required, and then it can actually call my method. Another example would be Twilio, where I can put in a URL that needs to be called when people text messages to my special text number that I would get with Twilio. So you can start to see how you can actually very quickly respond to some other service without having to write a whole load of code around it. We can also be triggered if something gets added to blob storage, so if we upload an image, for example. Or we can have event hubs, part of the IoT suite of services in Azure. If an event fires, we can respond to that. If an item is put into the Azure storage queue, we can actually have an event and we can trigger and respond to that, and we'll actually see what comes in the queue. Or we can actually use Azure Service Bus, which of course is like a high-speed bus system, which can have queues and topics. So also let's look at inputs. Now, the trigger is the thing that makes or causes the Azure function to start. And of course, we can pass in parameters if we use a URL, for example. But there are actually inputs you can bring in as well as the fact that your function has been triggered. So we can actually pull in some blob storage data or some table data. We can do access to a NoSQL DB. We can use an Azure Mobile Services record, or now we can even use the bot framework. So imagine that, for example, the bot framework is set up or bot service is set up. So when somebody types something into their Skype window, wherever they're using that's connected into the whole system, that you actually get a call or request to fire a function, and an input of that is actually something that's been typed in through the bot framework. You could then see how perhaps you could have an output from that where you can actually start having a conversation just by channeling the bot messages through your single Azure function. And that, of course, can refer to other things. So it could be quite powerful if you do that. On the output side, there are kind of many more choices. Of course, we can store things in a blob or in a table or in a queue as part of Azure storage. And we might quite naturally, if you were doing a response to an HTTP request, do an HTTP response. So as you saw before, our simple function just took a request in and then sent something back, including some of the data we already sent. Of course, you can output to an event hub. You can also output to a service bus and a mobile record. Another interesting one is that you can actually send to a notification hub, opening up the possibility that you very easily attach in to sending notifications to a broad array of devices, because of course Azure Notification Hub deals with not just Windows but iOS and Android as well. And you can send back to the bot framework, as I was saying before. This means that you can have this conversation going just by pushing everything through an Azure function. And we'll see that the Azure function is actually quite capable of taking simple parameters in, or posted fields in, or a stream in, or from different sources, for example. You can also talk to services like SendGrid, where you can send mail to people, so you could just use that as part of your overall solution. And Twilio allows you to send text messages. So there are some scenarios that we can think of that become possible when we start messing around with these Azure functions and those inputs, outputs, and triggers. The simplest case, or a generic case, is timer-based processing. So there's something that has to happen maybe once a day, once a minute, once every so many seconds, where you want to do something or at least check if something needs to be done. So that's timer-based processing. It kind of makes sense. And you can have multiple timers firing off, or rather multiple functions, each with a different time based on them. So, for example, if you added in a new file into blob storage, you could get this event that that file has been added. Maybe it came from a mobile application. When that happens, you can fire a function, and that could do something with that information, either just the fact that it happened, or it could take that thing. So, for example, you could be uploading a new image, and the image needs to be processed in some way. Maybe you actually just put it into another queue. You can also do SAS event processing. So, for example, you can plug into a situation where somebody adds something to their OneDrive, and you're able to respond to that, maybe make a copy of the file or do something else. Think of serverless web applications, or SPAs, a single page application where you're pretty much downloading just HTML once, and of course CSS and JavaScript that goes with it. And then a lot of the data, or even the format of the page from then on, is dictated by data that comes from maybe a handful, or maybe even just one endpoint that you're talking to. That endpoint, rather than being a whole ASP.NET MVC framework or a framework on another platform, could actually simply be one of these functions. Obviously, you don't want to get crazy complicated here, but for some websites, maybe all you have is a contact form. You just need to send something, and it does a mail. So you could respond to this request, and then turn around and use the send grid output to send some data out quite easily. Just as you could use the serverless functions as a backend for a web application, or a single or multi-page or simple number of page application, you could also use it for applications that have entirely native clients and have a backend that's driven by normally, say, ASP.NET or Azure Web Services or some other web framework on some other platform. And all you just need is a few calls to get a few things done. For example, maybe you just need to be able to log in and be able to get a token that allows you to upload files. So maybe there's only one method you need to call. Maybe it's authenticated and uses OAuth, but that one method is all you need to get a token that allows you to then directly talk to a storage system and store some images or files or whatever it might be for an appropriate amount of time as well. Things could get quite heated when you're talking about millions of messages, over a short number of seconds. And so there might be simple things you might have built into your existing code, which would perhaps increase the memory usage or otherwise bloat a process if you're processing a large number of messages. If you consider using these functions instead to do some heavy duty processing, you're just basically making a web call. You can kind of fire it off and use the thread to carry on with some other process. And when it comes back, with the heavy processing may be done through Azure Functions or elsewhere, or just giving you scale where you don't need it in other respects, then this is a really great use of, or really good distribution of load. And we've mentioned this already, real-time bot messaging. The idea that messages will come from the bot system, come to you through an Azure function, you decide what kind of witty response you might want to send back, and off it goes back into the system. So just let's take a deeper look now at that API or webhooks thing that we do, and that triggers a function, and then the output we can get back from that. So this is the trial version that we're looking at here. I'm actually going to go directly to functions.azure.com, and it's going to try and log me in and give me access to my full Azure account, where I can actually create a regular instance. So here we'll say we'll have a new function app, and I'll put it in Canada Central. So I'll click create and get started. So here we've opened up inside the regular Azure portal, and I can click what I did before, the webhook plus API and C# and do create this function. Skip this because I think I know what I'm doing. So let's look at this again. But we just won't rush through the trial experience, although you do get a whole hour to play with it. But this way we don't have to worry about it timing out, and we can actually add multiple functions in and see how those play together. So if we just look through what's happening here, we actually have this web request come here, and we have a tracer object we can use. So we can actually log things and they'll go somewhere. Then we actually check to see if there's a query string. If there isn't, then maybe there's something in the body that we can pull out, and we look for name in both cases. And then we just check if we've got name of null, then we actually say, hey, just pass something in, please. Otherwise, we say, oh, hello, whatever we passed in. So it's pretty simple. Now, I did before copy this URL and put it up here. You'll notice this very long piece on the end here. I'm just going to switch that out, and we'll talk about that in a second. Change this to anonymous and save that. Come back to develop. So instead of copying out, we're just going to click run. So I'll click run, and you'll see this log comes up here. So this is a log of what's actually running. In fact, it's the log of the actual method. If I went and called this from the web browser somewhere else, you'd see it appear in the log down here. So it happened, and things went through, and we got these little messages that came through here, and it apparently something got returned. But let's go over to this test thing here and bring this in, and we can actually see the output that we're getting back from the method. So this is a very good test harness situation, and we can see the logs that have been created for this specific call as well. You can see that we can actually put in a JSON body here. So name and Azure went in, and so hello Azure came out. If I go and try for get, I can do this as well. I can add a parameter. Confusingly, this is actually called name, so we actually have to type name on top of that. And then I can say Colin. And now if I run it, we'll use the get method instead, and so it says hello Colin. So I've got this test harness that I can use here. I can pause the whole thing, clear it, I can copy these logs, move things around a bit. If I go to the integrate tab here, I can see that the trigger is HTTP coming in. There's no specific other inputs, and the only output is the HTTP return. You can see that the input is mapped to this parameter name, and we're just using standard mode rather than any specific webhook pattern that works for, say, GitHub, for example. So if I go back, you can see that rec is the thing that has to be passed in, and there's some binding that goes on when this method gets called. You can also see that we're doing a using statement as well. That's great. We can do some web calls. Let's just talk a second about security. I changed it for anonymous to anonymous just so we could get on with things. You can have key-based, so you saw that very long string that was there before for the functional overall admin level. Of course, those are kind of things you don't really want to have necessarily in your application on the mobile client or even coming to a web browser, because people could see those things. So you can actually do OAuth and use the providers for Azure Active Directory, things like Facebook, Google, Twitter, and of course, Microsoft Account. So those things are all possibilities for securing that endpoint, so it's just not out there for everybody to hammer like crazy. So let's look at doing HTTP trigger, but going into an Azure Storage queue. So we'll go and create a new function, and we'll go for this one, which is HTTP trigger C#. You see we have quite a few more options here as well. And we'll call this HTTP to queue. And we'll set this to anonymous, and we'll click create. So this kind of looks like the one we had before, because it pretty much is. But what we want to do is we want to output to a queue. So we'll go into integrate. And not only will we get a web response back for when we try and do something, we're actually going to do another output. So go to Azure Queue Storage right here and select. I already have a connection string configured, so I'm already connecting to a specific storage account here. That's great. You'll see that it's going to assign this output queue param as a parameter that needs to go in the method that I can then use to actually put things into that queue. And we have a queue name, so we'll call this one Techdays 1. So that's the queue it will actually create if it doesn't exist. So we'll save that. Then we'll go back to develop. So it didn't automatically update something important for me, and that is I need to go in here and I need to paste this in here. So that's the additional parameter that's coming in. I can actually just have the output queue, but I can't have an async method with an out parameter, which is what it would be. So I'm actually pressing in this collector that can add multiple things. So I could queue many things from this one function call. So we'll make a few changes down here. We'll say if name equals null, then we're going to return this. Else we'll return this. And we'll just check that this still builds. When you click save, it will actually compile every time you save. So still looking good. Actually just run it again, still says the right thing. That's all good. So now, if we actually have a name passed in, we can use our output queue item, and we can call add, like it's a list, and we can add something in here. So we'll actually add in name. So that will get added to the queue. So I'll actually call save, make sure it compiles. Looking good so far. And then I'm going to do a run. So we'll do run. Everything went well. Everything's good. And this has actually been placed onto that queue. And I could use kind of the Storage Explorer to actually go in and take a look into that queue if I wanted to. But rather than do that, what we'll do is we'll do like a counter method or counter function. And that one's going to read from the queue and do something with that. So I'll create another function, because why not? And we'll go down here, and what we're looking for is a queue trigger C#. We'll call this one queue to log. So we'll just log whatever comes in. So the queue name is actually Techdays1, same storage account. So we'll click create. Now, I don't know if you noticed this, but it actually already ran because it's active the minute we put it in there. We can actually go into manage and disable it if we wanted to, but it starts enabled. But the method actually got called once already because we had something in the queue. So if we go back again to HTTP to queue and change this to be hello and run this, and then we go back to our queue to log, you'll see that that one came through as well. So it's basically giving us some sort of scalability because we could be queuing work items into this queue and then doing something more complicated with them. Perhaps the first one gets triggered not by HTTP, but by, for example, something being posted into blob storage, like an image. And the classic example then becomes, well, okay, I see you put the name of that image or the URL to blob storage for that image. And then I'm going to pick that up, and I'm going to resize it and put a thumbnail version of that and make that available for download later on. And then if we really want to go kind of nuts on this, we could do this. We can have a new function, and we'll call this one so this time we'll go for timer trigger in C#. And we'll call this timer to queue. Now this is actually the cron pattern for launching. This is every 5 minutes. So we're going to be a bit more adventurous than that, and we're actually going to make it every 5 seconds. Why not? So we'll create this. And just like before, we're going to have to integrate that queue. So we need a new queue output. And so it's the Azure Queue Storage. Click select. That's going to be the way it was before, and this has to be the same matching queue name, so that's Techdays1. And here's we've got our connection like before. So we'll click this. Everything else is fine. We're going to need that parameter again like we had before coming into the method. So I'll go to develop and we'll add that in here. And then I'm going to do output queue item dot add datetime dot now dot second dot toString, like that. And let's just save and see if that works fine. So compilation is successful, and it will be running on its own. So we'll just clear this. You can see it runs. You can see when it ran, and then what we'll do is we'll actually go into queue to log. Clear this. Make sure this one runs. So we'll go back to this queue to log. We'll just fix this to be output queue item so that the names match, like that. Then we'll go to develop. Aside from me renaming the variables there, sometimes the log output stops working. It has to be refreshed. There we go. Now it's syncing up nicely, and we have the seconds coming through. So you can see we're pumping things into one queue every 5 seconds, and we're pulling them out of this queue, of the same queue, also every 5 seconds. So I'll just go back to here, go to manage, and I'll actually disable it for now. So you got to see the queue trigger to log, and then the timer trigger to queue output. So we saw both of those things. Let's try something a bit more sentimental. Now we'll create a new function, and this will be a standard HTTP trigger request, and we'll call this sentiment. Change this to anonymous and create this one. So here's our standard pattern that we've seen before. Now we're going to make some changes. Now the first thing we'll do is an add ref. Yeah, that's actually add ref, but we can't do it within Visual Studio. So we actually do this. Newtonsoft.json is so obviously going to be required in so many cases that it's available, and all you have to do is mention it and you'll get it. There's actually a way to add in other NuGet packages as well. Then we're going to need some other using statements, like so. And then we're going to need some classes so we can understand the service we're going to talk to. And that's actually the Cortana Cognitive Services or Microsoft Cognitive Services. So we'll declare some classes here so we can talk backwards and forwards to that. We'll need a key, which I'll destroy afterwards in case you feel like copying it. So I'll put that down here. And then we'll need a bit more code. So we need to fill in a few things. So we'll come in here, about here, and we'll fill this in. So we have this address that we're going to point to, which is the API endpoint for the sentiment services. And we'll create a structure in code, and we're going to pass in whatever name and a unique ID for every instance or every time we call it. Then we have another huge piece of code to bring in here, like so. This actually creates an HTTP client, which works because we have the using statement. We use that JSON to convert this into a string. That will become the body. And we need to add in that we're using application/JSON. We need to pass in this key so we actually get access to the services. And there's a certain amount of free services available just for you to play around with. A month is quite a generous amount. We're going to pass this in, and we want to get JSON back. We read that as a string. We kind of log that out. We deserialize what comes back in, and then we pull out the score for this, or the sentiment score, and we actually log that. And in fact, what we'll also do is say here sentiment, and that will be this. So we'll actually log it, and it will be the thing that gets returned back from the web request. So let's see if that builds. It does, that's great. So now it's going to pass in the word Azure. Let's see how it reacts to that. So the function was actually successful. You can see this is what I passed in, and this is what came back. And in fact, as it turns out, Azure gets a high sentiment score of 0.96, and it is actually out of 1, not 100. I don't know, let's just, why not? Oh, 0.89, not quite as good. Surprise, surprise. But we can put things in that obviously make more sense, like this is a great session. There we go. Or, you know, hopefully not. I wish I was still in bed. Yeah, not so cheery, that response. So you can see how we can start doing very useful things with just this. I mean, it's not a small amount of code, but it is just one code file effectively, and there's no whole infrastructure or app model or anything else around it. And of course, I could actually take this URL, paste it into my browser, put a query string on the end, use name, put a whole string in there, and it would just give me a result straight back to me. So let's just, why not do it? Just paste in name equals great. There's the answer, sentiment of 0.99. Of course, this could be a whole web page comes back, or some JSON data that we use in a single page web application. So let's just do something a bit more. We've done storage of simple strings into a queue. We've done HTTP in, and we've returned some stuff. Let's deal with some images now. So come in here and add in a new function. Be C#, and it will be thumbnail maker. And anonymous again. Create. So there we go. We're going to have to add in quite a few using statements, but also 2 add references in this case. We'll do this. And we'll also add in some more using statements. Like that. Make sure that builds. That's good. Then we'll come down here, and where we had name, we're going to change that to URL, because that's what we're dealing with, just so it makes more sense. So that's changes, that changes, that changes. That one, this one, and not least of all over here. Just check that runs still. All good. And now what we're going to do is we're going to take that URL that's being passed in, and we're going to use it to go and get an image, and then that image will come back, we'll resize it and pass that image back to the caller. So I'm just going to replace a chunk of code from here to here. And just make sure it builds. Good. So what we're doing is using HTTP client. We say we're actually looking for a JPEG. We go and get that. We get it back as a stream. Then we actually create this image from that input stream. We also need to have an output stream ready that we're going to fill in. We create the image, the thumbnail image, down to 120 by 120, and we put what we're doing into the output stream, wind this back, create the response, use this as the stream content for our response content, put the appropriate headers in, and say we're doing a image JPEG, and then we send that response back. So let's just go and get a URL of an image that we can use. And I'll put it right in here. I'll just run this. So you see what's coming back in the output window is obviously binary data. I should also make sure that get works as well. I'll just do a get, and then this will become URL. Same thing there, run that. Same result. So now we know it's working. So let's just go and check what the image is. So just run the image. That's a picture of me, obviously. And then we're going to go back to here. And we're going to take this URL, copy it. I'll go to here. It's actually URL equals, so just copy that. And it's going to be there. And then we'll want something else on the end, which will be the picture URL. Put that on the end, and off we go. So there's the small version. If I switch between the two, obviously one is a thumbnail. So now we've used a function to do an on-the-fly resizing based on the URL that was passed in. Obviously, this is not secure. It shouldn't be anonymous, and we shouldn't just let it pass in any URL. It probably should be to some blob storage that we're actually responsible for, so we can at least check that it's going into the right location. So we actually use the libraries that are already present. You can actually get hold of NuGet and npm. That's Node Package Manager libraries if you're using JavaScript to get hold of other things, and you just put them in a JSON file that's declared as part of the interface there that you're playing with, and then it's possible to have those libraries actually come in as well, which is great. Some best practices to consider. You need to be focused. We don't want these functions doing 5 different things. They should perhaps be separate functions. Be stateless. There is no really, you can store state in a database, but you shouldn't assume that if you'd ever be the same instance of the function being called. It just doesn't work like that. This is you basically the state is only as long as the method is running. Be idempotent. Hopefully you understand that in terms of if you do the same operation twice, you should get the same result. It shouldn't make a further modification or same addition. So if you're doing a creation operation, you want to make sure that you're passing in some sort of creation ID so you can make sure that you don't create 2 of something. And be quick. Obviously, you should use async and not kind of asynchronous code, but obviously you want this thing to be as efficient as possible. So speaking efficient, there's always money to be spent somewhere. You can actually choose with Azure Functions to run this in one of 2 ways. You can run it as part of an app service plan, in which case it goes with the scaling up and down of that there, or you can actually just go for individual executions with some resource usage. So you actually get 1 million free executions a month if you go on the consumption plan, and you get 400,000 gigabyte seconds. That's in terms of the amount of memory that's being used for a second over the month. So just that's quite a lot. And then over that, you only pay 20 cents per million executions and a ridiculously small fraction of a cent for gigabit seconds above that. So that's you'd have to be doing a pretty large scale app to start really racking up a bill on this. And it comes with the same 99.95 3.5 nines availability as well. Oh, and the whole thing, by the way, is actually open source. That includes the functions runtime, the portal code, some of the templates, the WebJob SDK, and extensions that the whole thing runs on top of as well. So if you want to try it, go to functions.azure.com. You have the opportunity to click on try and pick which way you want to go with your function. You get an hour. You can start again after that. You need an account to log in with. I think it's Microsoft, Google, or LinkedIn. And there's more details on functions at this link, easy to find. Thank you very much for your time today.